Okay, so welcome back to the second part of this lecture. So let me see the presentation part. So yeah, can you see the slide? Hello?
Yes, sir, we can
Yes,
see.
sir.
Yeah, this caching we are discussing. So let's move on. Uh, Yeah, the next one is actually here. We'll try to discuss about. So far, if you look at, actually, we discussed about broader architecture of computer, where we discussed about different peripherals, memory, and then the CPU, bus, and so on. And now here, from this slide, actually, you can able to, here we'll discuss about more of like the number of processes and all the systems that depends upon the systems based on the processes, whether it's a single processing system or like a multi-processor system. And also based on that, some we'll try to discuss about very briefly about how the systems will be in the multi-processor case and the single processor system and all. So here, as you mentioned, that most of the systems, earlier systems, are the having a single processor, which is a general purpose processor. It means that it performs all types of activities like arithmetic operations and even other operations also. Like it's a general purpose processor. Only one processor will be there, and all the applications, whatever is supposed to be run by the system and all, it will be taken care by the same CPU. And then now you can see that now the most, and then along with that there will be some special purpose processors also will be there. For example, like along with the general purpose processor, you can have some math processor will be there, like used to perform mathematical operations. For example, a floating point processor. It means that if you need to perform a floating point operations and all, then that particular activity will be carried out by a floating point processor, which is specialized in that. So likewise, we have some special purpose processors also as well. But coming to the context of multi-processor means where we have more than one processor will be there. More than one processor will be there, and these are also known to be like a tightly coupled system. It means that we have one system where we have multiple processors will be there, right? And also known to be parallel systems and all. So since we have multiple processors or multiple CPUs instead of one, you have these advantages like the throughput can be improved, right? And it's more economical also for the given increase in the throughput, right? Throughput is more means actually the number of instructions, or you can say that the number of applications that can be run, and so that can be enhanced using a multi-processor system, obvious, because instead of one processor, if you have four processors and all, you can run the four instructions in parallel, right? But it's not all the time, but you can do that. And then economy of scale means actually here, for example, you have a system with the four processors, right? And compared to that, you have four systems where each system having a single processor. So the cost wise, it's very economical having a multi-processor system under. Here in the case of multi-processor system, if you see that the processors are more, like processors are more than one, but the remaining peripherals, you can say that the bus and the memory and IO devices, they are remain same or more or less as a single processor system and all. So that way, in the economical perspective, if you have a multi-process systems and all, it will be like economically very effective for the given improvement in the throughput and all. And at the same time, the reliability also more, because since it has a multiple processors are there, so even though if one process is like had some problem, so the remaining process will take care of the applications without much degradation. That means the performance degradation will be there with the effect of graceful degradation. Means like earlier actually you have performance of like whatever the number of jobs that will be carried out at unit time. Now it will be like, suppose one processor is down, for example, then the performance is reduced by that particular factor, right? Suppose, for example, earlier there are four processors, now we have only three processors running. So with the 75% efficiency, the system can able to perform the jobs. That's what I mean by the graceful degradation. And
Right.
since you have multiple process, you can use it for a fault tolerance also. Means actually, if you can able to identify the like a faults that happen during execution, if at all, so those things also can be carried out by properly arranging the process as a pairwise, and the same instructions will be run by both the process and will check the output. If the output differs, then there is a problem in the one of the process or something. So that way you can able to analyze the faults also. And so these are the basic advantages of having a multiprocessor system. It means a system having the multiple CPUs. And in these multiprocessor systems, the way they work, the way they can be used in the two types, known to be asymmetric multiprocessing and symmetric multiprocessing.
Sir, I had a
And
doubt. Hello.
yeah, yeah, please.
Yes, sir. I am
Uh,
telling that. Sir, like if there are, sir, in multiprocessor systems, like the all the processors would be sharing the computer bus and like all the peripheral devices and all, right? So, sir, wouldn't there be like wouldn't uh, it cause some slowdown of
yeah,
the individual processor's capacities? Because then what is
correct.
essentially the
Correct. You said whatever you told, it's correct. But what I'm saying is that that slowing down is there. But if you compare with the single processor, if you compare with the single processor, that still the performance, there will be a chance of performance improvement will be there. That means here, suppose you have multiple process, as you mentioned, single bus, single memory and all. So all four process need to access the bus and all. It will be slowed down. But if you properly coordinate the jobs or applications, if you properly do the programming, if you do
Sir,
it,
sir, I'm saying like sir, there may be many operations where like the different processors cannot handle independently. Like after the output of one processor, only we
yeah,
can feed the input of. Sir, in those
exactly.
cases,
No, right. Yeah, exactly. That's there. It's not that actually the improvement is not the folds like multi-fold. It's not like the directly proportional to the number of processes. That's what I'm saying. You have a complexities are what I mean to say. Suppose you have a quad core processor, that is, you have a four processors are there. It means that actually the running time of all the jobs are enhanced by one fourth or enhanced by four times. It cannot be. It cannot be. What I'm saying, throughput is more
yes,
means actually the number of jobs that will be done with respect to single processor, it will be more. That's what the enhanced throughput. It's not, yeah, whatever you mentioned that exactly true. Like you have, when you given the job to multiple process and all, there should be coordination, there should be communication among the process, everything happens and all. So that way, sometimes a processor need to be wait for the output of some other process, some synchronization has to be done. So all these things will be there, but still, even then, in spite of that, you can have the performance improvement, and it will be much cheaper compared to having multiple systems and having connectivity. So that's what I want to mention. So all those things were there, the
and
complexities,
also,
whatever you mentioned.
sir,
Hmm?
sir, wouldn't there be any compatibility issues between the processors?
No, not compatibility issue. No. If it is really, if there is something compatibility means what?
Sir,
Compatibility means you have a process, and you are giving a job based on that. The nature of the job, actually, the process, the job will be allocated to the multiple process and all, right? By using an operating system in a coordinated way. So that way it can be done. Actually, there is no compatibility issue at all. The thing is that sometimes you need to have, like, it's not that all the process will run 100% of the time. Sometimes a process may wait for something, and otherwise actually some jobs maybe takes more time, and also that happens. But on the whole, overall, actually, you can have the improved performance. That's what I meant to say.
So in fault tolerance, you said like same instructions can be run on two different
Yeah,
CPUs, right?
that no, yeah. If you wish, actually, if you want to have a much higher order of fault tolerance and other things, where you can able to do it like the same job, same instruction sequences will be given to the both the process, and then their outputs will be tallied and all. So if there is any difference and all, then you need to inspect the like one of the processor and all. So that way you can able to do that.
So they'll have to be synced before we run the process, and also they
Yeah,
can
yeah.
have different frequencies, right?
No, not different frequencies. You have to give the same clock and same thing, the same thing, the same exactly the replica. And in that process, if there is any difference, then it has to be worried about. That's what I mean by. Yeah. And then coming to here, the asymmetric and symmetric multiprocessing, the way these things are differ will be like both are applicable for a multiprocess system. In case of asymmetric multiprocessing, and among the process, one process acts as like a kind of master, and it tries to coordinate the jobs given to the other process. So that way, the relation between the among the process will be one will be like a kind of the master, a coordinator. The other will follow the whatever the jobs assigned to them, they will be taking care of that. So in the case of asymmetric multiprocessing, sometimes happens that the process will be some process are specialized. Some process are specialized. As I mentioned, like we have a process like a floating point processor is there. It means that it used to perform the floating point operations very effectively. And there is some other processor which is specialized for performing certain tasks and all. So that way, in case of asymmetric multiprocessing, so based on the task or based on the programs, so the different process will be assigned to the different process based on the nature of computation and all. So that way, the asymmetric multiprocessing, the relation between the process will be kind of a master and slave kind of a thing. The master will coordinate the different process, assign the jobs, looking at the status of the processing, and all those things will be done by asymmetric multiprocessing. Whereas the symmetric multiprocessing, there is no such master-slave relationship is observed and all. Here, all the processes are same, having the same capability. Like almost like all the processes are the general purpose processes and all. And the load, whatever the process will be shared or will be passed on to the different process by the operating system using some scheduling criteria, so that the job will be done in a more effective way. So yeah, here the basic difference is that in case of asymmetric multiprocessing, as I mentioned, that one acts like one of the processor acts like a master, and other will it will coordinate the other process and all, and it used to assign or it used to pass the process to like other process based on the nature of the job and other things. Whereas the symmetric multiprocessing is not that way. Right. And then coming to the multiprocessor architecture, this is one way where you can see here there are 3 CPUs were there, and each CPU has the specific set of registers and a cache, but all of them access the main memory, the same main memory through a bus it is to access. And here these 3 processors are in the 3 different chips. They are the 3 separate chips. Each processor is a separate chip, and they are connected to the bus, and then they can able to access the memory, and there is a built-in cache is there. And there is another way of configuring the multiprocessor system where in the same chip, here there are 2 processors, but both are housed in the same chip. This is a core, this is the same chip, and within the chip you have the 2 CPUs were there. And here this again, each CPU, it has its own registers and the cache and all, and both of them access the main memory. And here the difference between these two is that here in this case where the multiple CPUs or multiple processors are in the separate chips, and the coordination or the communication between these 2 processors has to be done with the like across the chips, like by using interconnects and all across the chips. With that the communication has to take place, or the data transmission, whatever can be done. Whereas here, since both are in the same chip, so here the communication between the process will be much faster or higher compared to the earlier structure and all. In the earlier structure and all, because each CPU will be on the separate chips and all. So if there is a communication that is required between the process, like across the caches, across the registers, and across the process. So in that case, actually here the communication will be like offline. You can say that off-chip communication, right? So using some connectivity, copper connectivity, you can have the data transmission. Whereas here, since is within the chip and all, so therefore here the communication will be much faster. So here this is the dual core. So likewise, you have a quad core, octa core, and so on. Then coming to the next thing is that having multiple systems, but here this is a clustered systems where like the multiprocess systems, we have multiple systems can be put together. And yeah, all of us, whatever right now we are connecting through internet, various systems and also the same way. And since here the difference between earlier and this one is the earlier is like we have multiple processors within a single system, whereas here we have the multiple systems itself and they are connected through a network, like through a network with the net connectivity following the network operating system and protocols. And you can view the teach system as a node and then the communication between the nodes and other things. And since you have multiple nodes, again you have the clustering can be, you can analyze, can be viewed like the what way the clustering works, whether it's asymmetric clustering or symmetric clustering. So the principle is same, like similar to the one earlier I mentioned that. In case of asymmetric clustering, there will be one machine can be viewed as a hot standby mode. It means that it just monitor the server, whichever is actually carrying out the tasks and all. And if the server had a problem, or in that case, then it will take over that hot standby mode will take over that server functionality and all. Whereas in case of symmetric clustering, there is no such hot standby mode. So here all nodes are same capability. And if there is any problem and all, then one of the server or the whatever the particular nodes functionalities will be shared across the nodes. So that way these two differs, asymmetric and the symmetric clustering and all. And basically these are used for sharing the storage aspects. Like you have a data somewhere in the one storage system and all, then all these computers will store this, will share this data and yeah, you can use it for and like for example, suppose there is a bigger task that can be carried out by at a different systems parallelly by properly program that particular task and all. So that way you can able to do this. Then coming to the concept of multi-programming in the context in view of operating system. So far we discussed about multiprocessor or multiple systems putting together and all. So in that case, what is the role of operating system is again the same thing, how to make the system to be more efficient in the perspective of throughput and the response time and the overall functionality and so on. So that is so that way that architecture will affect or the corresponding operating system is required. And then the other aspect is that actually having the system, you have a system having a multiprocessor or like a single processor, how to make it like more effective using a multi-programming concept. So here the idea here is that multi-programming, the idea, simple thing is that suppose a user cannot make the CPU or IO devices busy at all the times and all. A single user make the system CPU and IO cannot be make it busy or effective all the times. So that's where this multi-programming concept will be there. And here is nothing but actually here it will organize the jobs so that the CPU will execute one after another and all. And here the concept of jobs means actually here earlier actually the I mean to say that like 30 years, 40 years before, most of the activity or most of the tasks or most of the computation that is performed by the computers will be not much user interaction. They doesn't need much user interaction and all. Not much user interaction is required. So that means that you need to give the data or like you had to give a program and data files, whatever is required at one point of a time. Then there is not much user interaction is required and that job will be performed, carried out like one after another and all. So this is what mean by the job here in the context of multi-programming or the job scheduling. It means that you are feeding the multiple jobs to the computer. And then, for example, one job is executing by the CPU. And for example, if that job needs the IO, for example, then the CPU will not wait for the IO completion. The job will be taken out and that job is waiting for IO and the IO will be taken care of that. And the next job will be placed. So that way the CPU will be made busy all the time executing one or other the job and all. And here thing is that here the job, as long as it needs the CPU and all, so it keep on using the CPU, and whenever it needs the IO, then it will come out of that, and the CPU will suspend the job and it will be passed on to the IO queue, and then the CPU will take up the next job. So that way the job scheduling or the context of the term mean by jobs and other things means that one. That means the programs or the processes that point of time will be, most of them are non-user interactive, right? But the inputs, whatever is required and all, they will be available from the files and also it will take the data from the files and whatever that can be done. But thing is that nowadays actually the applications, most of the applications where a lot of the interaction, user interaction is required from time to time, the applications, whatever, suppose you are filling a form, for example, then after filling each entity and all, again you try to see that what is the response and all, then based on that you are feeding something else. So that way the applications are mostly the user interaction. A lot of the applications are the interactive applications. It means that the user want to see that the progress of the application or the progress of the task from time to time. So in that case, if you go by the normal multi-programming, where the user cannot see the progress of the job from time to time. So therefore, actually here the concept of time sharing is coming to the picture. So here in case of time sharing or known to be multitasking, here the idea here is that the CPU will allow the job to run a fixed time slot, some finite amount of time slot. And once the time slot is over, still the job may need the CPU, but still the CPU will offer its computing for some other job, next job. So that way here, the case of time sharing or a multitasking environment, the idea here is that the CPU will handle the jobs in a fixed time slots, where the time slots will be usually less than a second or in the order of milliseconds. So that even though we have larger jobs, even though we have so many jobs are running, but you have each job will give a file at every 1 second you have a chance, every job have a chance to visit the CPU and all, right? So that way, in case of time sharing, the idea here is that the CPU switches jobs so frequently. So with that, the human user, he didn't feel that his job is like pending or it's waiting for something, because for every second, almost like he will get a chance to see the progress of the job and all, because you are giving a time slots in the manner of like millisecond, order of milliseconds and all, so that almost like each job, whatever is there in the queue, have a chance to visit the CPU, like almost like very frequently, like in less than a second and all, so that you can able to see the progress. You can able to see the like what is the next status of the job and all. So that's what mean by the time sharing or a multitasking and all. So here the idea here is that the response time should be, because as a human users, our human, for us, the response time will be less than a second and all, so that we'll feel comfortable. Otherwise, we'll feel that yeah, we don't be comfortable, right? And then each user has yeah, at least one program in execution, and it's not to be a process. A program that is in execution not to be process and all, because you can see the difference between the program and a process and all. A program means actually a program that is there in your executable file. If it is there in your secondary memory or a disk, it's inactive. It's just a sequence of machine codes just occupying some space. But whereas the program, if you brought into main memory and if you pass on for execution, then it's active, because that program needs the different resources and all. It may need the IO, or it may need some other thing. It may need the CPU cycles. So then you can say that it's a process. That means a process means a program in execution, not to be processed. It needs the resources and all to carry out its execution and all. So that's the difference between a program and a process and all, right? A process is nothing but program in execution, not to be process, right? And yeah, since there are several jobs are there, then you need to have some kind of a CPU scheduling is required, because there are lots of jobs you need to perform multi-programming or a time sharing, whatever it is. You need to have that the jobs has to be like, you can have the CPU scheduling is required. And then if a process, for example, if a process is so big or if a program is so big, if it is not fit into memory, then in that case, you should have a mechanism to, like you need to make some space to be empty from the main memory. You had to brought in some memory, or you had to bring only the partial program into the memory. So this is known to be a process of swapping and all. Swapping means actually here If the process doesn't fit into memory, then you will just bring only the part of the program into the main memory and all. Then when it's executing, then afterwards, suppose if it requires the code which is not in the main memory, at that time you need to swap. You need to swap means by that time assuming that your main memory is full and you need the instruction that is not present in the main memory. For example, it's currently running some program and the next instruction will be somewhere or at some instruction which is not in the main memory. So at that time you have to, for execution of that program, you have to bring that memory. You have to bring that particular the instruction sequence from the secondary memory to main memory and assume that the main memory is full, for example. So in that case, you need to have a strategy that you need to vacate, you have to make some free space from the main memory and you have to bring the other one. So that's not to be swapping. So free space means because my memory is full, that means you have to vacate, you have to make some memory space to be free. So for that, what you have to do? So that memory space, whatever the content is there, that has to be placed into the secondary storage. And then from the secondary storage, you have to bring the program whichever is right now required and all. So that process is not to be swapping and all. So that all these things will be taken care by the operating system. And in this context of swapping and all, you need to have the involvement of virtual memory or not to be the secondary memory is also required. Because here the concept of when I'm just introducing a new term virtual memory. So actually the CPU doesn't know about the secondary memory. CPU has access to only main memory. And if the content is not there in the main memory, then it's the job of somebody or operating system to bring the content to be brought into the main memory, right? So for that purpose, actually here, since as I mentioned that since the entire program cannot fit into the main memory, so you first you part of the memory will be brought in, and afterwards, if you need the further remaining part, then you have to bring into the main memory. And that remaining part will be kept in the will be placed in the secondary memory because
Hello, hi all. Vivek this side. Am I audible?
Yes.
Yeah. So sir got disconnected because of power cut, and he may not join like in some time. So at 11:45 you all have the mock test. It will not be evaluated, but it's for the for monitoring purpose, like how test will go. So everybody have to attend the test and don't leave the meeting because we may have some announcements for the meeting. Okay. So till 12 you don't have to leave the meeting, and at 11:45 take the test. Okay. Over the meeting you can communicate your issues if you are facing any issue, or you can post it on the chat. Okay. I will try to stop the recording. Let me check. So is there anybody who left the meeting? And if there is anybody who is going to give the test directly, please tell them to join the meeting first. Please communicate. If you can.
Hello?
Yes, sir, you're audible.
Yeah, right. Yeah, here the somehow the power went off suddenly, and now I just connected through hotspot through my mobile for this one. So let me see whether the recording is going on. Yeah, I think yeah, something is going on. Fine. Uh, yeah, what I just I'll try to conclude, and then you can able to move on to because now 11:36 actually. Let me conclude this, and so can you see the slide now? The earlier slide, whatever. Hello, hello.
No, sir,
Not
we
yet,
can't.
sir.
No, sir.
No, you are not able to see. No, okay, fine. So it means actually I have to again. Yeah, let me see. Yeah, and can you see now?
Yes, sir. Yes, sir.
Yeah, right. So let me just conclude in just 2 minutes. Then after that, you can take the exam, no? Because it was scheduled at 11:45. Right now, the time is close to 11:40. No? Okay, so yeah, what I mean to say is that in case of multi-programming context, there are two ways. One thing is that the like the earlier way of multi-programming, where the jobs are or the programs are non-interactive. So in that case, the kind of the operating system's role or the CPU scheduling is not that sensitive because the jobs we are passing on a job, you can say you can use the simple job scheduling kind of round robin approach where the jobs are placed in a queue and the jobs will be offered to the CPU. As long as the job needs the CPU, it uses the CPU's time. And afterwards, whenever it needs the IO, then the CPU will take up the next job in the queue. So that is a way, but still you can, it's a multi-programming where the CPU and the other things will be, you can make it busy. You can make it more effective or the utilization will be, you can make it reasonably good. But the problem, not the problem at all, because the programs are the tasks that are of that nature. They don't need the much user interaction and all. But the applications, the present applications where needs the most of the time the user interaction is required, or user want to monitor the progress, user want to see the response from time to time. So in that case, the way of multi-programming will be like a time shared manner, where the programs or the process will be given to the CPU with a fixed time slot. And after the time slot, once the time slot expires, then the CPU will take up the next process. And for controlling the time and all, you have some timer, hardware timer will be there. It maintains a counter. And whenever the job is assigned to the CPU, at that time a counter will be set. Then the counter will be decremented with respect to clock. And whenever the counter reaches to 0, that time the CPU will be informed. Like because the timer is a hardware device, it sends the interrupt whenever it reaches to 0. Then the CPU will realize that this time slot is over, then it pass on to the next. So that is the way it happens. And in this process, it requires these things like CPU scheduling is required, swapping may be required, concept of virtual memory where the content of the data content will be moved between the secondary memory to the primary memory. So these things are required in the context of that. So yeah, now we'll stop at this point, and now you can be ready for you continue in the meeting itself, and then take up that at 11:45 you can able to access the mock test. And the mock test, I had given the 10 questions. There are multiple choice and a simple 1-word, 2-word answers and all. It will not take even 10 minutes also, but I have given a slot of 15 minutes and all. And you please try to answer them. Another thing is that actually, and since there is no timer in that question paper, that means when you are answering that, there is no timing information for you. So that is the reason that I'm asking you to be in the channel, the general channel, so that the TAs will announce the time and all, like the last 2 minutes or something like that they will announce. The problem is that if you don't submit within the time slot, then your whatever your form is not recorded. So it is completely lost. There is no way of tracking that. So it's very crucial. So that is the reason that actually when the TA says that the last 1 minute or last 2 minutes tender, so please try to wind up. So please try to submit whatever the state you are. Otherwise, no, if you delayed, if you don't submit, then it's a problem. It's a problem is your submission will not be there, and then there is no way that we can evaluate your form, your answer sheet. So please adhere to that. Since we don't have timer, it's a manual way of doing that. We'll do that. So please, whatever the given time, you please look at your watches, keep your watches, and then try to answer that within the time and all. So now I'm stopping here at this point, and I'm stopping the recording also.
Excuse me, sir.
But
Excuse me, sir.
yeah,
Sir, I have a small doubt.
yeah.